So 3 raised to power x equals to 1 over 81, that is D. Now this is already in its smallest base ever. So leave it like this. It is this 81 that we can say this is 1 over 81 is 3 raised to power 4. Okay, so we have 3 raised to power x equals to, of course, when you have a fraction like this, the denominator can come up and take a negative power. So this one becomes minus 4. Now of the same base, equal base equates power. So therefore, s equals to minus 4. Now, last question, we have 10 raised to power minus s equals to 0.000001. 1, 2, 3, 4, 5, 6. So we have this one as 10 raised to power minus s. Of course, this is a decimal number. And then you can convert it to a standard form, or you make it a fraction. That is 1 over, let's count the number of tens, 1, 2, 3, 4, 5, 6. That is 10 raised to power 6. Okay, 1 over 10 raised to power 6. Okay, now, or you say 1 over 1, 2, 3, 1, 2, 3. That is 1 over 1 million. But you have to still convert it back to an index. That is 10 raised to power minus 6. So this 6 now can come up. This 10 raised to power 6 can come up and become 10 raised to power minus 6. So this 10 and this 10 will go. Minus 6 equals to, minus s equals to minus 6. Minus take care of minus, and s equals to what? S equals to 6. So that's it. Alright, we want to go into another aspect of exponential equation that may be reduced, to a quadratic form. Okay, when looking at the question, you will know that this is going to end in a quadratic form or equation. Now, some exponential equations can be reduced to quadratic forms, as we show below in example 2. When you see questions like this, you will know that this one will definitely lead to a quadratic equation. One, look at it, is equal to 0. A quadratic equation is always equal to 0, and the highest power of the functions or of the expression, the highest power of the unknown used in the expression must be 2. That is how you know a quadratic equation. When the power of the unknown is 2, being the highest power ever, then you know it's going to reduce to a quadratic equation. So any equation, any exponential equation of this form must be reduced to a quadratic form. Now the idea, the techniques to now use to reduce it is what you need. Okay, now let us look at this question. We have 5 raised to power 2x minus 26 into bracket 5 raised to power x plus 25 equal to 0. Now, the first thing you do is that look at this. They have given you a kind of hint that this is the simplest base ever and is raised to power x. You must try as much as possible to link that. You link this, let this 5 raised to power x be in your factor of the first expression. The first expression is 5 raised to power 2x, but what you have here is 5 raised to power x. Okay, try as much as possible to bring out 5 raised to power x in your first expression. That is the logic. Now, how do we achieve that? This is 5 raised to power x, everything raised to power 2. Do you agree? Because this is 2x. Interchange them. Let x come here and 2 goes there. And make sure you put that 5 raised to power x in bracket so that we can have something like this. You understand now? So you can see that x times 2 is still 2x. It does not change, but it's a way, a technical or tactical way of getting that. So minus 26 into 5 raised to power x plus 25 equals to 0. Now, for simplicity, okay, or for convenience, so that it will be easier, let P, or let 5 raised to power x equals to P. Do you understand now? Why do I do that? Is because I want this 5 raised to power x to represent a particular letter, or a letter to represent it. So that when I finally get that, I can replace it back for convenience. So anywhere I see 5 raised to power x, I am putting P. We now have p squared, because this one has been replaced by p, with p. This is now p. So p raised to power 2 minus 26p. You don't need to even put it in brackets. Minus 26p, then plus 25 equals to 0. Do you see now? So now, you can see that naturally it has reduced to a quadratic equation. This is what we are talking about. Now, what are the factors? We have 1 multiplied by 25. You know, that is how we find factors in quadratic equation. So 1 times 25 is 25. What are the factors of 25 that can give us the middle term? Okay, that is, can we say minus 25, because this is plus 25, can we say minus 25 minus 1, or minus 1 minus 25? You see the same thing. Minus 1 minus 25 will give you minus 26. Then minus 1 times minus 25 will give you plus 25. You know the normal step where in quadratic equation. So now we can now have our p squared minus this 26 now will be replaced by minus 1p minus 25p. Okay, now plus 25 equals to 0. You know that there is nothing like 1p. 1p is the same as p. So this one naturally is gone. I will now factorize the quadratic expression. Now that you have 4, you can make it 2 here, then 2 the other side. So for the first two functions here, can we say p is common? So p into what is left here, we have p minus, we have factorized p out, so it's going to remain 1 here. Then minus, between 25p and 25, what is common? 25 is common. It's going to remain p, then minus 1. Don't forget that when you have minus 1, in the first bracket is p minus 1, the other bracket is also p minus 1. You must have the same factors in the brackets, okay? Alright, we now have p minus 25 outside, p minus 25. Pick one of these, p minus 1. This is equal to 0, this is equal to 0. So we can say that either p minus 25 is equal to 0 or p minus 1 equals to 0. So you can take minus 25 to that side. So p is equal to 25 or p is equal to minus 1 goes to that side, we have 1. Now, this is just the value of p. This is not the solution to the question. Don't forget that the unknown used in the question is x. But it was because of convenience that makes us to use p. After you have gotten that value of p, you now replace back the value of p. So we have two values of p. You will not solve them one after the other. When p, okay, you can say recall that for convenience sake, we said let 5 raised to s equals to p. Now, for each value of p, the first value is 25. Okay, when p is 25, so can we say that is 5 raised to s equals to 25. 5 raised to s equals to 5 raised to 2. 5 and 5 can go, s equals to 2. This is the main variable given to us in the question. So s equals to 2. That is one of the solutions. Now also, when p is 1, don't forget that they also give us 1. When p is 1, the expression is 5 raised to s equals to p. So p is now 1. Now this is 5 raised to s equals to, you will now be wondering, what will you do here? How can you make this one to be of the same base with this? What you do is just simple. Law of indices. The third law of indices is that anything raised to 0 is 1. So anytime you have that, for us to have a base of 5 here, just say 5 raised to 0. 5 raised to 0 is 1, and it has given us what we need. We cannot use another base. We can say 2 raised to 0 is also 1, but it does not fit what you have at the left hand side. So that's why we are using 5. Now 5 and 5 will go, so s equals to what? S equals to 0. That is the solution. So therefore, s equals to 0 or s equals to 2 is the solution to the question.